Today's focus is on physical and chemical changes. So one problem and dilemma that chemists run across a lot is that we have two substances that look very similar and yet we don't know exactly what they are. So we have to come up with ways to distinguish between one versus the other. For example, if you had hydrochloric acid, it is a clear liquid. And it looks very, very, very similar to water. It looks identical, actually, if you just look at it. And so how do you differentiate between those two? And so what they do is chemists use physical and chemical property differences to determine the differences between different substances. Okay, a physical property is something that can be observed or measured without changing a substance's composition. So if you know that sulfur is yellow and you have a yellow powder and you have a white powder, then you can say that it's not one of its physical properties of sulfur, so therefore it's not sulfur. Okay, a chemical property can only be observed by changing the composition of the material. And when you do that, this is the key, it changes the identity. Okay, that is the key difference between something that is physical versus chemical. A chemical property actually changes what it is made out of, not just what it looks like, but what it is actually made out of. Okay, so it's no longer just sulfur, it's sulfur and oxygen. Okay, so to test its chemical property, let's say it's flammable. That would be a chemical property. But in order to observe if it's flammable or not, you would have to try to light it on fire, right? So when you light it on fire, it's no longer the same thing. So here are some examples that you will have to note on which ones are physical, which ones are chemical. There's a few that I really, really want to emphasize. First, physical, you have melting and boiling points. Anything that is a phase change, okay? Those are all physical, okay? Even though it looks different, like let's say melting of water or ice. So you have ice and then it melts into water. It is a phase change. It looks totally different. It was a solid and now it's a liquid, but it's still made at the composition level of H2O. It was H2O before, it's H2O in the end, okay? Color, density, so how dense is it? Malleable. So malleable, just to let you know, I always see the word mallet in it, and malleable means to be able to be beaten into thin sheets. Okay, so like an idea, something like that would be aluminum. Aluminum, the metal, can be beaten into thin sheets to make aluminum foil. Conductivity, can it conduct electricity? Magnetism and hardness. Note, whenever I look at any of these properties, I'm not actually changing what it's made out of. I'm just observing, making observations. Chemical properties, on the other hand, I'll be changing what it's made out of. So can it rust? Does it decay? Does it burn? Can it ferment? Or does it react with? These are all chemical properties. In order to observe them, I will need to actually change what it's made out of. So let's go over some basics. Properties of water. So you're supposed to identify whether it is a physical or chemical. So water expands as it freezes. It was liquid water and now it is frozen water. So that would be a physical change or physical property. Hydrogen peroxide decomposes to produce water. So we started off with H2O2, we end with water, which I know you know is H2O. So did I change what it was actually made out of from H2O2 to H2O? Yes, I did. So therefore that would be chemical. Water boils. As I mentioned, it's boiling, which is going from a liquid to a gaseous state. And as I mentioned in the previous slide, anytime it is a property or a state of matter change, it will automatically be physical because it's still made out of the same substance. When electrical current is passed through, so we're talking about is passed through water, it seems like right when I read that, I'm like, oh, we're talking about conductivity, which is a physical change. But then if you read further, it says, when I start with water, I end with hydrogen and oxygen. Okay, they're separate in this. So I started with H2O and then I end with hydrogen and oxygen separately. So in this one, even though I talk about electrical current, I'm not talking about the conductivity of it. I am talking about me actually decomposing and making it into something else, which means that it is chemical. This is the last one, and this is a very tricky one. Salt can dissolve in water. So you would think, oh, it's dissolving, it's disappearing. Obviously, it's chemical. If it is reversible, it is going to be physical. So is there a way that I can use salt and water that is mixed together and separate them again? Yes, I can use their boiling point differences. Okay, water has a lower boiling point than salt, so I could evaporate off the water and get salt. If you can use a physical difference, then it's to be able to separate them, such as boiling point, melting point, magnetism, that is a physical property. Okay, dissolving is always a physical property. But if you can use one of these other techniques, a physical difference, then that would be a physical change. All right. Now, here are your physical changes versus chemical changes. This is where you're actually changing what it looks like. So by me observing that it's blue, I'm not actually changing what it's looking like. That's a physical property. That's not a physical change. Okay. A physical change will change the appearance, but it doesn't, once again, change the composition of the material. That is, once again, extremely, extremely important. That is the difference between physical and chemical changes. Physical change, you're just changing what it looks like. Chemical change, you are actually changing what it is made out of. So here are some examples of ones that you're going to need to know. You've got all of these states of matter changes here and here. You've got different appearances like crush, diffuse, condense. That's another state of matter change. Cut, split. Once again, these are all changing what it looks like in this particular one. Like if you're cutting or splitting, cracking, that means that you guys are like making it smaller particles or smaller pieces, but you're not actually changing what it's made out of. Okay, and then you've got all of these guys where you are actually changing exactly what it is made out of. Now, this is another thing that you want to ask yourself, is it reversible or is it not? If it is reversible, it typically will be a physical change. If it is not, it typically will be a chemical change. Now, one example of where it's a physical change where it's not reversible is if I like cut a piece of paper, right? I can't get that piece of paper back as it is. Okay, people then are like, oh, you just use tape. Well, but that's not the same thing, right? You're just putting it together, but you're not actually making it whole again. But I didn't change what the paper was made out of, so therefore it's just physical. All right, so these are the 6 signs of a chemical change, and this is going to be very important when you are identifying whether it is a physical or a chemical change. You want to look to these 6 signs of a chemical change. If you have 2 or more of them, you are going to, you should say it is a chemical change. Right now, your basic understanding of chemistry is very small, so it's going to be difficult for you to identify whether it's physical or chemical. So you need to go to these 6 signs in order to identify whether it's a physical or a chemical change, probably. Unless you've had some of them memorized, then you can just go with what you've already learned. Okay, so let's talk about a little bit of these. We've got a color change, gas production, temperature change, light, precipitate forming, and irreversible. Okay, make sure you always remember irreversible. That's a key one. Okay, that you'll use a lot. All right, so a color change. So if you actually see the color change, okay, notice that a color observation was a physical property, but because it's changing colors, that would be a chemical property typically. So we've got a color change. It's like an example is is heating up an egg, right, or cooking an egg. Any type of cooking, just to let you know, cooking, baking, grilling, those are all going to be chemical changes. So we have the egg white. Look at how it changes colors. So that would be an idea. That's a sense of a chemical change. Gas production. So you see bubbles being produced. Now make sure that they're just being produced not because you are adding heat to it, such as like when you are boiling water, you also see gas production or bubbles being produced, but you're adding heat and you're trying to just change a state of matter. So make sure that you're like careful on what these observations are. Remember, these are not all the signs, but if you see multiple of these signs, then it's probably going to be a chemical change. Okay, so if I saw both a color change and bubbles being produced, I would say it's a chemical change. Temperature change, that means it can give off heat or absorb heat. Okay, so if you see a temperature change, so it's either releasing heat or absorbing heat, so it goes up or down in temperature, that would be a sign of a chemical change. Light being produced, so if you strike a match or fireworks, you see light being emitted, that is a sign of a chemical change. This is the one that is definite. If you see this, if you see that, you are 100% going to be having a chemical change. This is also the observation that none of you guys probably have seen before, okay? When I say a precipitate forms, I am not saying precipitation, which is rain. I am not saying that. It is not making rain, okay? This is chemistry. So what we're talking about is actually, if you look to the right, you have two liquids. Okay, so notice I have a liquid and I am pouring it into another liquid. In this particular case, they are both clear liquids. So that's the start of it. Okay, you have two liquids, and what happens is you actually make a solid and it still is a liquid. The solid can look cloudy. Okay, it's not going to make like a crystal, it's going to be powdery. Okay, but it really will look foggy or cloudy to you. In this case, this is like as he's actively pouring it. And so this is your cloudy solid, okay? It will make the whole substance look cloudy and foggy. It's like when you look into a creek and it's like really dirty water, okay? That's got some solids in it. That's why it's dirty, okay? If it's not see-through anymore, therefore it has some sort of solid particles in it, okay? Now, this cloudy solid substance, this guy is your precipitate. Okay, so the solid is the precipitate. The liquid is not the precipitate. So when you get two liquids and they combine to make a solid and a liquid, that solid is known as a precipitate, and that is a guaranteed sign that a chemical reaction occurs. All right. I also want you to remember that you also have the sixth sign of irreversibility. Please become familiar with those, and remember, if you have two or more of these, then you should go with that. It is a chemical change. Have a great one.